team, organizing member who are really a backbone to organize such kind of webinar or any kind of FDP workshop. Because through my personal experience, I know a lot of work, background work we have to do, a lot of parallel things we have to handle. So really, it is very appreciable to the team of Truba, Professor Chandan sir, Sonal madam, and other members, Tyagi sir also, that are really working behind to make it successful. And also, I would like to appreciate RGPV, especially TechTube department, Chaube sir, who are really very generous to allow to organize affiliated institute to such kind of FDP, and they also provide sufficient fund so that they can run such kind of programs that people can learn from them a lot of things. Okay, so good afternoon.
Good
I'm
afternoon,
audible.
sir.
Sonal, I'm audible.
Yes, sir, completely audible.
Okay. Something happened from my side. That's why I'm a little bit confused. Okay. So, good afternoon, everybody. Myself, Dr. Vivek Tiwari from Triple IT NAR, Raipur Computer Science and Engineering Department. I welcome you all participants again in this 2 days webinar on that is related to the data science and R. So, today topic I have taken that is related to descriptive data analytics using k-means clustering algorithm, and I will also implement all those things by using R. So first, let me explain what the things I'm going to cover throughout this session. Basically, 3 points I will put more focus over there. First, I will start discussing about the k-means clustering that comes under the descriptive data analytics. I will also explain k-means clustering through all possible example, numerical example, all the distance functions I will take in consideration. I will explain its working through the numerical example. And the last, I will try to demonstrate how you can use k-means clustering for a descriptive analytics. For that purpose, I will use platform R. To the same purpose, if you are comfortable in the Python, MATLAB, or any other language, you can choose as per your comfortable. Because internal working and concept are similar, and it is a matter of only syntax. For a today discussion, I will take a platform R for the demonstration. So without wasting a time, I'm going to directly start with the today topic clustering. Okay, so this MS Word file is visible to everybody. Okay, I can also.
Yes, sir, it's
Yeah. Okay, so the first line you can consider over here that comes under the clustering. You can say what is a clustering? Clustering is an unsupervised descriptive data analytics. There is a two word I have highlighted with a different color. The two word is the unsupervised and descriptive. Means clustering is an unsupervised and descriptive data analytics. First, I will explain what is a descriptive analytics, because there are, you can consider a lot of sub branches under the data analytics. So majority of the people talk about there are three sub branches under the data analytics: descriptive data analytics, predictive data analytics, and prescriptive data analytics. With the limited time, I'm not touching other branches of the data analytics. I will talk about little bit about the descriptive data analytics. As the name suggested, descriptive data analytics is something that we normally use to describe our data. Once we have a data, a lot of data may be related to any application you can imagine. Maybe many applications you can imagine. Maybe video applications, image application, text data, numerical data, continuous data, what kind of data you have. So you want to describe your data. Okay, then somebody may ask, what is the meaning of describing the data? Describing means, suppose you are running a business, and in a business something happened. Maybe suddenly you are feeling a lot of benefit, and you may start losing in your business. So you want to know something happened. What is the cause? what is the reason behind that happening. So in that case, you want to know the answer of particular question, answer of particular questions with respect to the data. Then you require a descriptive data analysis. Or you want to search some pattern, some artifact, some trend that is hidden inside the data. If I put a lot of huge amount of data before you, by looking the data, you can understand. You cannot understand anything. So you require some tool that will scan your data multiple times, and after scanning, it will give some result. These are the hidden pattern, artifact, and some trends are they can get from the data. So you can take further another decision. So you know something what is hidden inside the data. All such kind of processing comes under the descriptive data. One nice thing I want to share with you all, data visualization. Whatever the data you have, you might have, you all of you have gone through such kind of process. Statistical, you want to see the statistical property of the data. Means what is the average age of student or the final year student? What is the average package of RGPV affiliated institute? What is the average salary? What is the mean salary? And what is the interval? As a lot of statistical term I can list over here. So if you want to know all the statistical term comes under the descriptive data analytics. If you want to visualize your data, maybe by using bar chart, maybe by using heat chart, heat map, a lot of visualization tools are available, visualization algorithms are available. So once you go for a visualization, it also comes under the descriptive data analytics, because by using a single bar chart or pie chart, you are describing your data. Okay, that are very simple about the descriptive data analytics. And there are some a list of example, list of algorithm that comes under the descriptive analytics are like that. Clustering is the one of the example, are the descriptive analytics. Another example is association rule mining. Many of you, I hope, know the association rule mining, like a priori algorithm or frequent pattern growth algorithms comes under the descriptive data analytics. One more feature extraction algorithms are I'm able to recall, that is called PCA. I think many of you also listen that word. Principal component analysis also comes under the descriptive analytics. So the clustering is a descriptive data analytics, plus it is unsupervised learning. I also hope that many of you know there is a two sub branches of the machine learning algorithm: supervised learning and unsupervised learning. Supervised learning, if you see the data, the answer is given to you. Answer in the form of the class level. There is a one feature will be there. Normally the right hand side column. The answer is given to you. So what you need to do, based on the input feature, you have to map your data input feature to the output feature, because the answer is given to you. So you can recheck every time the way you are mapping the data with the input feature to the output feature, whether that mapping is correct or not, because you have the answer to check whatever you are doing, and whatever the results you are getting, that is exactly matching with the real answer or not. So here, what is the real answer are given to you in the term of class level. They are used to supervise your process. They may correct your process. That's why all the algorithms that comes under that category is called supervised learning. Means all the classification algorithms, Bayes, KNN, decision tree, random forest, logistic regression, linear regression, all comes under the supervised learning. In the unsupervised learning, there is a no answer given to you. You have to continuous apply some process. Whatever the answer you are getting, you cannot recheck it, whether the output of finding you are presenting over here, that is a correct or not. So no supervisor over there. That's why it is called unsupervised. So at least with this set of discussion, we can easily talk about the clustering is something that comes under the unsupervised learning and descriptive data analytics. I think that is enough for the introduction about background of the clustering. Now you try to see the PPT or the screen. The definition is given to you there. So I never recommend to memorize any definition. A lot of kind of definition may be available, may you get from the Google, and there is no any single qualified algorithm that somebody will claim that is a perfect algorithm. So there is no perfect algorithm. So keeping the content very simple, I have included very simple clustering definition here. I'm going to read it out. So clustering is the task of dividing the population or the data point. In normal language, we normally talk about the data, but in technically, data is not a correct word. Technical word is the sample or population. Either you can use the sample word or population that represent the data, whatever the data you have. There is a huge difference between the word population and sample. I am not going in that level. So correct word is the population. Population means the data you are talking about. So clustering is the task of dividing the population, or for the simplicity, you can say the data points into a number of groups. These number of groups normally we call the cluster. So what is the clustering process? Whatever the data set is given to you have to apply some process that is called clustering. Clustering will do something for you and divide your data into different group or different cluster, such that.
Vivek sir, sorry for interruption. Actually, the contents slide is visible to us right now. There is a heading contents. That slide is visible to us.
Oh, that's why I asked. Okay, so actually, there is a .doc file. Let me do it again.
Okay, sir.
That's happened in the online. No, no, no. Stop sharing. Let me do. Mm, Now it is better.
Yes, sir. A Word file is shared right now.
Okay,
We are able to
sorry
see
for
Word
that.
file.
I was discussing that point for the many last 10 minutes. That is the definition of the
But we
clustering over
understood,
written
sir.
here. Okay, not ISO, not ISO. So that is the line I was explaining in the last 10 minutes. Clustering is it's unsupervised descriptive data analytics, and I have explained in detail what is the meaning of descriptive word over here, what is the meaning of unsupervised over here. So that thing I was explaining, not ISO. So I was reading that line over there. The clustering is the task of dividing the population or data points into a number of subgroup that is normally we call the cluster, such that the data points in the same group or same cluster are more similar to each other than the data points that belong to the another group. What is the meaning of that? Whatever the data set is given to you, you apply the clustering process. Clustering process will divide your data into number of subgroup. The number of subgroup that is called cluster. Now we have to check the property of the cluster. The property of cluster should be like that. All the data points that belong to the same cluster should be similar to each other. And they are should be much dissimilar to the data points that belong to the another cluster. So what is the meaning of similarity over here? I will explain in detail further down the line discussion. So what is the meaning of similarity? When I say the data points are similar to each other, what is the meaning of that? How can I quantify the similarity? How do I know these days if there is two algorithms and both the algorithms are comes under the clustering and applied on the same data, how two algorithms are performing, which is better than other one? So there must be a mathematical formula that will quantify the similarity among the data points like that. So I will discuss in detail what is the meaning of similarity over here. So for this moment, you can understand applying the clustering process, the result will be a set of data points, a data set of group, such that data points that belong to the same group should be similar, and it must be more dissimilar to data points that are that belong to the another group like that. Okay, so go to the little bit more detailed discussion over there. There is a two bullet point. One bullet point saying about that cluster. Now I'm talking about the single group. After the clustering, there may be 100 cluster, maybe 20 cluster, maybe 5 cluster. Each cluster should be like that. I'm going to discuss about that. The cluster means a single group. Is a cluster is a group of objects that belong to the same category or share the similar property. Again, that criteria I encountered again. Earlier, also we have seen in the definition, the cluster is something, a group of data items where the data items share the same property or they are similar to each other. I will also discuss in detail. Next point, very important. Normally, people forget to discuss this kind of important point. While doing the cluster analysis, we first partition the set of data into the group agree based on the similarity and then assign the label to the group. That is a very important point you try to understand. That somebody will ask a question between difference between clustering and the classification. So normally what we talk about the clustering is unsupervised learning and the classification is a supervised learning. Very correct answer. But more better if you explain that clustering generate new information, new knowledge. Supervised learning or classification never generate the new knowledge. The clustering generate the new knowledge. How? I will explain it with the example. Suppose this data set is given to you. That data set is belong to the some vendor. So you can consider like a DMart or you can consider like a big bazaar. So suppose I am the owner of the big bazaar here over here, and that is the customer, all the customers' data of last 5 year or 10-year data you can consider. So whatever the data I have applied a clustering algorithm. Suppose a clustering method I have applied and assume that the clustering process divided our data into the two subgroups. So clustering process may divide your data into multiple, maybe number of cluster, maybe 2, 3, 5, 10, 20, 100, 200. So there is no single rule. But for the simplicity, I'm assuming that whatever the clustering algorithm you have applied on data, the clustering process have divided your data into the two subgroup or two cluster. One is the red color cluster, one is the blue color cluster. Agree? So the clustering is not a magical process. It only divide your data. Once you have a cluster, you have to analyze your cluster with your own knowledge and try to see the what kind of property of a red color cluster contain, what are the other property blue color cluster can contain. So assume that we have a two cluster, red color cluster and the blue color cluster. And when you analyze the data items or customers that belong to the red color cluster, you came to know all the customers who are in that red color cluster normally purchase the electronics item. So that the property you get it know after the clustering process over. Then each and every cluster you have to go into the detail and then you realize that the customer who belongs to the red color cluster are electronics item lover. So normally whenever they visit our shop, they normally purchase the electronics item. Similarly, after the deeper analysis, you get it know that the blue color cluster, all the customer belong to over there, they normally visit our shop for the grocery item or daily use item they normally purchase. So that is the new label we are talking about. In the point two, we are talking about we can label the groups. Label the group means we can give the new name of that customers that belong to the particular group. Like here, all the customer who belongs to the red color cluster, normally we can give the new name to them, electronics item. Similarly, other group of customer we can give the new name, grocery item. So what is the advantage over there? Advantage over there, the later, suppose the new electronics items that vendor want to launch. They have a new TV, a new music system they have. So they want to have advertise their newly product. So it is not good to send a message or to call or to send an email to all the customer they have. They only send this kind of information that new music system or new electronics product they have now. They will try to contact only those customers who belong to the red color cluster, because they are normally purchased the electronics item. So what is the benefit of that? Benefit of that is that they are the vendor don't need to invest a lot of money to contact to each and every customer over there. It is targeting only a small number of customers, so that there is a more chance to gain the benefit of them, because they normally all those persons they love the electronics item. So this is called target advertisement, target advertising normally. So they have to target. So these are the product. With that product, these are the set of people that are normally love that product. So how do you know these are the set of people? You know only by using the clustering model. So that is the example I have explained over there, how the clustering work with respect to our business, or how clustering can help uh, any manager or any owner of the company to take a appropriate decision. Now I will go a little bit in detail about that. So the main advantage of the clustering over the classification is that it helps find out useful feature that distinguish different group. Like in that example, we had a two group, red color and blue color. So the clustering help us to get it know how these persons are different to the person belong to the different group. So that is called useful feature. So if I say these red color customers are electronics item lover, means the new feature I have generated. So that the things I really wanted to make it clear. Clustering is something that generate the new feature, generate the new knowledge, where classification cannot do it. Okay, go to the next one. Similar example. Suppose this is the data set is given to you over there. Left hand side, the original data set. You applied the clustering process. Once the clustering process is over, the clustering process had divided the given data set into the three subgroup, where you can see these are the data items that are represented by the green color, means that is a green color cluster, that is a blue color cluster, that is a red color cluster. So why I have used that figure to explain something, because normally people also think about that clustering really physically divide the data, not at all. A lot of misconception I have seen with the new learner of the data science. They think clustering process physically divide the data, not at all. You see the data distribution of the original data, and the right side is the output of the clustering. The data distribution is intact. I am not physically moving any data. Means the relative distance between data points are similar, exactly same as it was in the original data. We have given only new label. Means these data items are the green color cluster, it's belong to the blue color cluster, it's belong to the red color cluster. So that the things I wanted to convey in the clustering, we never physically divide the data. We only give the new name of each and every observation. Now, technically, I'm going to discuss any machine learning algorithm, whatever the algorithm you know, or whatever the algorithm you will study in the future, always comes with the objective function. So there is no any machine learning algorithm that you can implement without any objective function. So what is the meaning of objective function? So you try to again see the example. Suppose that is the input data, or that is the output data. So in between something happens. The clustering process works in between over there. So whenever the process will take place over here, how system get it know I'm going in correct direction or wrong direction, because that is something we have to define some mathematical function, or something that continuous guide your process, whether you are in correct direction or you are in the wrong direction. So in the clustering, there's a two objective function. There is no rule such like that, a universal objective function that you can employ with each and every machine learning algorithm. Not like that. every machine learning algorithm is unique. It has its own objective function. There may be single objective function, there may be multiple objective functions. If you try to recall, you know about the linear regression. The linear regression least square method, or SSE, sum of squared error, is the objective function. You want to minimize it. Similarly, in the clustering, there is a two kind of objective function. What kind of clustering you can consider? I'm not discussing the k-means clustering here. I am discussing the background. I'm just developing the background right now. So there is a two kind of objective function. First objective function is that point within each cluster are similar to each other. That is called intra-cluster distance are minimized. That is called homogeneity. It is talking about a single cluster. Whatever the cluster you have, all the data items that belong to the same cluster should be close to each other. That is called intra-cluster distance should be minimized. Another word, it is called homogeneity. Another objective function is that points that belong to the different clusters should be dissimilar. So that is called inter-cluster distance should be maximized. That is called heterogeneity. So homogeneity, heterogeneity are two property. So once your clustering process take place, we have to check every time these two objective function, homogeneity and heterogeneity. If I'm increasing the homogeneity on heterogeneity, then my direction is correct. I'm going in the correct direction. If my homogeneity or heterogeneity is not increasing, I have to relook whatever I have done. So that is the only guiding parameter that will help you to run your clustering process. And these two objective functions are associated with any kind of clustering algorithm we have. Through the diagram, I can explain over there. Suppose if the full data set is given to you, after the clustering process, we have a three cluster, the one cluster, second cluster, and third cluster. And data points that are within the cluster, I am saying this should be density, this should be so dense. This should be very close to each other. So the distance between any data points, the distance between any data point uh, uh, within a same cluster, try to minimize it. Okay, so I was talking about that is a cluster, and within the cluster, these are the data points. The distance between these data points, we should minimize it. That is called homogeneity. And we have considered there's a three type of cluster. Now, when we talk about the heterogeneity, we consider one cluster as a single entity. So we have considered as a three single entity. We have a three cluster. Now, if you calculate the distance between two data points that belongs to the two different cluster, should be as far as possible, should be as maximum as possible. That is called heterogeneity. So I don't have time. Otherwise, with conceptually, I will try to explain why it is required. Somebody may ask the question, so what is the benefit of that? Why we need it? So why I want to maximize that distance? What are the benefit of maximizing that distance? So whenever next time we will have a time, we will go into the detailed discussion conceptually what is the benefit of those. For this moment, it is enough. I'm not going to discuss much detail about the application of the clustering. So I'm trying to focus to deliver much technical or mathematical part of the clustering. So clustering are normally algorithm you can imagine in everywhere, in every area, it's shown its applicability. So I'm not going to have a detailed discussion about the application of the clustering. I will jump into the more important discussion. Clustering is an umbrella, or clustering is a branch. Under that clustering, so many categories are there. Like in the screen, you can see there is a three subcategory under the clustering: partitioning based clustering, hierarchical based clustering, density based clustering. There are another method also there. There are another method also there, like rule based clustering. and I try to recall a grid-based clustering. So there are many subcategory under the clustering. So most famous subcategory of the clustering method I have listed over here. One thing more, these are the subcategory. These are not algorithms, single algorithms. I mean to say the partitioning based subcategory of the clustering. Under the partitioning based subcategory, there are many algorithms. One of them is the k-means clustering algorithm. There may be so many algorithms that comes under the partitioning based. Similarly, there are so many algorithms, clustering algorithms that comes under the hierarchical method. One of them is the agglomerative clustering. Similarly, there are a lot of density-based methods. One of them is the DB scan. So these are the some example I have over there. And with the limited time today, I will discuss only the k-means clustering. That comes under the partitioning method. What is the meaning of partitioning method? Suppose we are given a database of n objects, means we have n population, n number of population, or n number of number of rows or number of data points. And the partitioning method construct t partition of the data, k number of partition of the data. Sorry. So if n number of data items are given to you, partitioning method will try to make a partition of a given n data points into the k number of cluster. That is the value of k, where the k should be less than n. It is very obvious, because if suppose I give 100 observations, so how many maximum number of the cluster you can create? 100 cluster. You cannot create 101 cluster with respect to the 100 data points. So similarly, k should be always be less than equal to the data points are given to you. Again, I'm not going to have a much detailed discussion, because there's a two kind of clustering, soft clustering and hard clustering. It is the rule where k must number of cluster must be less than number of data points. It is the rule that is valid for the hard clustering. If you go with the soft clustering, the number of cluster may be larger than, may be bigger than the number of data points. Means if you have a 5 data point, you may create a 10 cluster if you are applying the soft clustering. But I am not again discussing much detail what is the soft clustering and hard clustering. 4. I am declaring over here whatever the things I am going to discuss over there, that is with respect to the hard clustering. Okay. So here it means that it will classify the data into the k group, means k cluster, which satisfy the following requirement. Now I'm going to have a little more detailed discussion about the clustering process. So whatever the data point, n number of data point is given to you, the clustering process will do the partition of the given data points into the k number of partitions, such that each group contain at least one object. Means it is not possible in the clustering process an empty cluster. The cluster must have at least one single object. At least there is not any possibility for an empty cluster. Second, each object must belong to the exactly one group. Means the sharing is not possible in the hard clustering. Means it is not possible to cluster share a single data point or same data point. Or in other words, if I say a single data point cannot be become a member of two clusters. So that is the two conditions over there that we have to follow. Like each cluster at least contain one object, or each object must belong to exactly one group. These two conditions comes under the hard clustering. Okay, that I was discussing about partitioning method. Under the partitioning method, I will go for a further discussion about the k-means cluster. So now it is the things till time I have discussed about the fundamental of the clustering process, their objective functions, and then and further we have discussed about the partitioning method. under the class partitioning method, I'm going to discuss about the k-means clustering. So the k-means clustering is so famous and perhaps most widely, most commonly used by the academician, by the researchers, and many applications. People have used the k-means clustering. People have studied k-means clustering. People have worked on k-means clustering during their MTech, during their PhD. So output of that huge amount of studies, that a lot of versions are available of the k-means clustering algorithm. So I will discuss here the first version, that is, you can consider the first time introduced by its inventor. So the very simple k-means clustering algorithm I will discuss over there. And if you want to go further in detail, you may explore its different versions. All the versions are you can find in the Google. Okay, so key points about the k-means clustering, I will start from over there. So the k-means algorithm assign each of the n example to the one of the k cluster. That is a very simple point. That is also a condition of the partitioning method. Means once you apply the k-means clustering algorithm on the data, whatever the data you have, suppose n number of observations you have, after the clustering process over, each and every data points must belong to any of the cluster. Another word I can say, it is not possible at all. Some of the data points are not member of any cluster. You cannot say like that. It is not possible. If there is a k number of cluster, if there is n number of data points, after the clustering process, all the data points must be a member of any of the cluster. Okay, so there will not have any chance for any data items are not a member of any cluster. It is not possible. That is written in the first bullet point. Second bullet point about the k-means clustering is that we are continuous talking about the k. So you can say that is the again limitation of the k-means clustering over there. Whenever you start the process, user has to define the value of k. K means total number of cluster. So now the quality of output is rely on the ability of the user. How can you say, suppose I'm the Dr. Vivek is a one user or one developer, and Dr. Ram is a second developer. Same algorithm is given to me, same data set is given to me. I have applied the k-means clustering process. I have applied the k-means clustering process by using k is equal to 2. And my friend may also apply the clustering process by is equal to k is equal to 5. Means two persons are made, they are independent to decide the initial value of the k. I may start my process with the k is equal to 2. My friend may start with the k is equal to 5. So now the big question over there, what is the ideal value of the k? What is the suitable value of the k? So if the user is able to decide or have such kind of knowledge where ideal value the user can predict, algorithm will give the correct answer. Otherwise the answer will or the results will not going to satisfy your applications. So the second point is talk about the same thing, where the suitable k is the number that has been determined ahead of the time but must be given in advance at the beginning. Meaning of that, when you start the clustering process, that you have k is a parameter, you have to decide the value of the k. That may be not ideal value, maybe that is a totally wrong value. But there is another method. Once the clustering process over, I will also discuss in today's lecture what are those methods that will help you to get it know that is a value of, or that is the optimal value of the k. So it is written over there. The k is the value that has been determined ahead of the time. Means later we can decide the ideal value of the k. But at the beginning you have to provide it to the system. Third point is already I have discussed. The goal is to minimize the differences within the each cluster. and maximize the differences between the cluster. It is talking about the homogeneity and heterogeneity. It is talking about the intra-cluster distance, inter-cluster distance. Minimizing the difference within the cluster means intra-cluster distance. They are talking about the homogeneity. Maximizing the differences between the cluster. It is talking about the heterogeneity. So these are the two objective functions that I have already explained in earlier discussion. So these are the some key points that you should know before dive into the much detailed discussion about the k-means clustering. Now I'm going to discuss about the procedure. Procedure means algorithm, typical algorithm I'm going to discuss over here. So there is a k-means clustering is the recursive process. K-means clustering is the recursive process. Recursive process means that they require some set of steps or statement that you have to execute multiple times. So there is a two phases you can see over there. The two phases under the k-means clustering are over there: updation and assignment. So what is the recursive process means? You can think like that: updation, assignment, then updation, then again assignment, then updation, then assignment, then updation, and then assignment. This process will continue go until some stopping criteria met. So what is the stopping criteria? I will also discuss. First, try to imagine that there is a recursive process. In the recursive process, there are two kind of phases: updation and assignment. These are the phases that continuous we have to execute until some stopping criteria met. Okay, so one by one we will discuss. The first step of the clustering process is that it assigns the examples to an initial set of K cluster. Means whatever the data points are given to you, it assigned randomly. You try to see the word randomly. It randomly assign the data point to the cluster. Okay, that is called assignment. The first phase is the assignment. Assignment means whatever the data point you have, you are making you are sending that data point randomly to one of the clusters. So you are assigning that data point to particular cluster. That is called assignment phase. Then what happened? Then update. The second phase is it update the assignment by adjusting the cluster boundary. So once you randomly assign the data point to the cluster, then you have to check something. I will discuss. You have to check something. So based on that checking, you came to know, oh, that data point X should not be a part of cluster. Data point X should be a part of cluster Y. So whatever the random assignment you have done, then you came to know some against couple of data points that assignments were wrong. Then you have to change the assignment. That is called updation. So that is written over there. It updates the assignment by adjusting the cluster boundary. Cluster bounding adjusting means only simple word. The data point that were the part of cluster X. Now I will remove that. I will make the data point X the cluster of another data point. Particular data point is the cluster of Y. So that is called assignment or updation. So that is written over there in the third bullet point. The process of updating an assignment occurs several times until changes no longer improve the cluster. Means that is an iterative process. It will continue go until some stopping criteria match. Some of stopping criteria also written over there. It will continue go until the changes no longer improve the cluster fit. So what is meaning of cluster fit? Cluster fit means same thing, that is homogeneity and heterogeneity. Those two objective functions we have covered. So whenever you updating the cluster and the result of that updation is that you are going close to the objective functions, means that the changes you have made is the correct changes. So you continue go on. There may be some time happen the changes you are making, updation you are making between the cluster, but that changes does not improve the homogeneity or heterogeneity, means that whatever the changes you are making, that is useless. You should stop it. So these are that is called cluster fit. Cluster fit means objective functions I am talking about. Simple, at this point, the process is stopped and cluster are finalized. So for the simplicity, I have also created one flow chart for making it very simple understanding. So again, I'm going to rediscuss the clustering process. At the start, we have to define the number of k may be 2, maybe 5, maybe 6. Randomly, you have to create the k number of cluster, and also you have to calculate the centroid of each and every cluster. Now I have to calculate the distance of every data point to the every centroid, and based on that difference, that distance, I get to know some of the data points are wrongly placed, because when with respect to the data point x, I calculate the distance of x to all the centroid, and the data points that are close to the which centroid should be a part of that cluster. So based on that distance, the data points that are closer to the which centroid should be a part of that cluster. We can make a updation. So here we again make the grouping based on the minimum distance. Yes, some stopping criteria. If stopping criteria match, algorithm over. Otherwise, again, it will go with the same process, because that is a recursive process. I will explain all those things through the numerical example. So if somebody have missed something or not able to understand properly, not satisfied, wait for 10 minutes. I will explain in detail. So before going into the mathematical example, let me discuss the stopping criteria in detail. Basically, there are three kinds of stopping criteria. First one is the changes. Changes means data points movement between the cluster. If the data points are moving between the cluster, but it does not improve the cluster fit, it does not improving the homogeneity and heterogeneity. At this time, we should stop our algorithm. Recursive process, we should stop it, because continuous moving the data points along the cluster, but my objective functions are not getting improved. I should stop it. Second data point is that it may happen data movement stopped. After some recursive process, you may assume that the cluster are converged. There is no possible movement of the data points among the cluster. Means no movement means automatically you should stop the clustering process. Third data point, third clustering stopping criteria is that set in advance number of iterations. It may happen sometime the clustering process continue that iteration continue go. So you can it is not possible you can wait for hours or 2 hours or 10 days or 20 days. It's kind of endless loop. So it is also highly recommended to set in advance like a number of iterations for my clustering process. Maximum number of iteration is 100. Before 100 iteration, if condition 1 and condition 2 match, then okay, that is called my cluster are converged. Otherwise, after 100 iteration, my algorithm automatically stops. And what are the cluster at that point they have, that will consider as a cluster. So these three are the stopping criteria. 1 minute. Okay, one request I want to make over here. If somebody having any question issue, they can write on the chat box. I have opened the chat box. So whatever I'm explaining, you want to ask them some question, you can write on the chat box. I will try to catch. I will try to catch all the questions you are typing over here. So that thing you can use for your understanding. Okay. So now, yeah. A little bit discussion about the distance matrix. Look, we're talking about a lot. We have to calculate the distance between two data points. We have to calculate the centroid of the cluster, and the data points that are close to the centroid should be a part of that cluster. So means ultimately talking about the distance matrix. We have to calculate the distance between two data points. So many distance metrics are available for you. You may create your own distance matrix. Only you need to calculate the distance between two data points. So Euclidean distance is the one of the famous distance metrics are over there. So you can use that distance matrix to calculate the distance of between two data points. So the formula is written over there for the calculating the distance between two data points by using Euclidean distance matrix under the two-dimensional space. If there's a three-dimensional space, you can extend over there. Through the example, I have also written over there uh, the distance between these two data points. You can fit into the formula whatever the value you are getting, that is called the Euclidean distance to data. If you are not happy with the Euclidean distance, or again a lot of discussion may be possible, what kind of distance matrix you should use, because a lot of options are available. A lot of options are available, like Manhattan distance you can use if you are not happy with the Euclidean distance. Minoxidil distance you can use. Spearman correlation you can use, or you can define your own distance matrix. So again, a lot of discussion over there based on the application, based on the characteristics of the data. You can use the appropriate distance matrix. The same k-means clustering, same data points. If you change the distance matrix, you will get a different clustering result. So the clustering results, whatever the final cluster you are getting, it is highly influenced by the underlying distance matrix you are using. So be careful. Do not casually apply any distance matrix. A lot of reasoning required. Suppose you are doing MTech or PhD, suppose, and at time of Viva, somebody may ask the questions, the distance matrix you have used, this one, why not other? Why you have chosen only Euclidean distance? Why other distance matrix you didn't try? What was the benefit of the Euclidean distance? In that way, you're supposed to know the answer. So that is the question I have thrown on you. You may have a further, you can explore, you can discuss with your teacher, with your books, and with your any colleague, what kind of distance metrics are available and what are the benefit of each and every distance. Question is there where we can learn in more deeply. As far as the machine learning is concerned, there is no any single book, no any single website. The way I have learned, I can explain my experience with you that only the Google. So many courses are over there. Coursera courses or MIT courses. So many courses are there. So many videos are there. You can search how to decide the distance matrix. A lot of video you will get it, and you have to go through each and every video, each and every website. So you have to try a lot. You have to read from many resources. Then later you get it. No, these are the way, these are the distance metrics, and the benefit of each and every distance matrix, limitations of each and every distance matrix, and which distance matrix work well with which kind of data set. So there is no any single answer. This is the book or this is the website you can study. No, you have to explore it. That is the answer. Now, as I promised, I will also explain k-means clustering by using the numerical example. It will really help you a lot to understanding a concept, because when you do study theoretically, a lot of things are not clear. So I have taken a simple data set only having a 4 observations, means 4 number of rows against 2 features. So the data set you can consider that is some medicine, A, B, C, D are medicine, and the weight of medicine is tablet is this weight and pH value also captured in the data set. So this is the data set having only 4 data points with respect to the 2-dimensional data. First, I will try to visualize it. Through the scatter plot, I have visualized into 2-dimensional space. So these are the 4 data points. Now, before dive into the detail, if I ask right now, you need to create a 2 cluster. So what will be the cluster? So anybody will easily indicate that these two upper side data items should be a part of one cluster, and these lower two data items should be a part of another cluster. So through your reasoning, through your understanding, you get it know if two clusters are given there, these two clusters should be like that. You can think like that. Now I'm going to demonstrate whether the clustering algorithm also will give the same results or it will differ from your expectation. So okay, I'm starting over here that like we have to decide the value of k. So the value of k is 2. You assume that the value of k is 2. You can start the value of k is equal to 5, 10, 3, 2, whatever you want, based on the number of data. So for understanding, for making it very simple discussion, I am deciding the k is equal to 2. So now try to recall the procedure or the flow chart of the k-means clustering. First, I have to randomly select the data point. So suppose I have selected these two data point as a two cluster. This is the cluster 1, k is equal to 1, and this is the cluster 2. Try to understand what I am saying. K is equal to 2 is given to you. So randomly you have to select a two data point as a starting point, as a seed point. Sometimes it is called seed point. Yeah, someone have written k means initializing the number of cluster. Yeah, I say yes. K is the initial. K means I'm explaining exact same answer over there. Whatever the k is given to you or you want to decide means that number of point randomly you have to select as a beginning, as a beginner, as an initial seed, as an initialization. So in this example, the k is equal to 2. Randomly, I have to select any two data point as a seed point, seed data point. So suppose this is the k is equal to 1. Suppose this is the k is equal to 2. Agree? Now, try to recall that flow chart. I have to calculate the centroid of the each cluster. So at the beginning, that is the cluster 1, that is the cluster 2. Cluster 1 contain only single data item. Cluster 2 also contain only single data item. So the centroid and data item value both are same. So suppose C1 is the cluster 1, C is the cluster 2, C is the cluster 1, C is the cluster 2. Centroid of the cluster 1 is the 1, 1 because there is a single data item. Centroid of the cluster 2 is a 2, 1 because it is a single data item. Try to recall the flow chart. I have selected randomly k number of cluster. Then I have calculated the centroid. What was the third phase? Third phase was calculate the distance of all the data points to the centroid of the cluster. That was the third step I'm going to explain. So that over there, that is the data matrix. The data represented by the matrix. That is the 4 data point, 1, 2, 3, 4. These 4 are the data points that are already given to you. These are the 4 data points. I'm talking about these 4 data points. I am representing that data points as a matrix. Okay. So these are the complete data set you have. This is a complete data set you have. Now I have to calculate the distance between all these data points to the centroid 1. What is the meaning of that? That is the first data point. I have to calculate the Euclidean distance between this data point to the centroid 1. Again, calculate the distance between second data point to the centroid 1, third data point to the centroid 1, the fourth data point to the centroid 1. It's very simple. So that distance output of that calculation already I have mentioned over there. 0 is the distance between this data point to the centroid 1 because these two are the same point. Distance between the second point to the centroid 1 is the 1. Distance between third point to the C1 is the 3.61. Distance between the fourth point to the C1 is the distance 5. Similarly, I have to repeat that process. I have to calculate the distance of all the same data point to the centroid 2 because there is a 2 centroid. We have a 2 cluster. Similarly, 1 is the distance between the first data point to the centroid 2. Distance between the second data point to the centroid 2 both are same, that's why distance is 0. Distance between third data point to the centroid 2 is a 2.83. Last distance is a 4.28. So the third step is already over, where we have to calculate the distance between all the data points to the all the centroid we have. Okay, so now I have to create a distance matrix. I already over. The final distance matrix is over here. When your algorithm you have to implement all the distance matrix you have to create. So for R, that helps you to find there is a concept of frame or data frame. By using the data frame, that is a data structure you can use to store the data and the distance also. So these are the distance with respect to the centroid 1. This is the distance, this is the distance with respect to the centroid 1. This is the distance with respect to the centroid 2. I combine that distance and try to make the distance matrix. So how can you understand that distance matrix? The first row represents the distance of all the data points with respect to the centroid 1. The second row represents the distance from all the data points to the centroid 2. Okay, so that is a distance matrix. After distance matrix, I have to assign, I have to labeling it, I have to label it. So what is the meaning of labeling over there? Try to understand. So again, I am going to have a detailed discussion, try to understand over there. That is the data point 1. Data point 1 have a distance from the centroid 1 is the 0. Same data point have a distance to the centroid 2 is the 1. So this is the same data point, and that represent the distance to the centroid 1, that represent the distance to the centroid 2. So you can easily understand that this data point is much closer to the centroid 1, because the distance to the centroid 1 is less than the distance from the centroid 2. That's why it is a part of cluster 1. So that is called labeling matrix. So the first row represent the group cluster 1. The second row represent the cluster 2. Similarly, with respect to the data point 2 is much closer to the centroid 2. So it should be a part of second cluster. Look, in the binary way I have represented over there. 0 means it does not belong to the cluster, and 1 means it belongs to the cluster. Similarly, third data point is much closer to the centroid 2, then it become a part of second cluster. Similarly, the fourth data point also close to the centroid 2, that's why it is a part of cluster. So now we can first iteration is over. After that first iteration, the cluster 1 contain only single item set, and cluster 2 contain the 3 item set. So the cluster 1 only having a data point A, cluster 2 having a data point B, C, and D. Agree? Now try to recall the flow chart. I have to again calculate the centroid. Okay. So group 1 means cluster 1 has only one member. So the centroid is 1, 1 means no changes over there. Cluster 2, earlier it had only one data points, now it has 3 data points. So now we have to again recalculate the centroid. So centroid of the cluster 2 is that is the average value with respect to the x coordinate, average value with respect to the y coordinate. That is a new centroid of the cluster 2. Now that is a iterative process. I have already explained the same thing. I will go with a little bit faster. So these are the distance matrix. The first row represent all the data points having a distance from the C1. These are the, again, have to calculate the new distance because the centroid of the cluster 2 has been changed. So now the new distance with respect to the new centroid. So now this data point is closer to the cluster 1. That's why it is a part of cluster 1. This data points closer to the cluster 1. Now earlier that data point B was closer to the cluster B, cluster 2. Now that data point B is closer to the cluster 1, so it will become a part of cluster 1. Remaining two data items are closer to the cluster 2 centroid. That's why it will become a member of cluster. So after the second iteration, you can understand that now cluster 1 having a 2 data items and cluster 2 also having a 2 data items. Earlier, the point B was a part of cluster 2, but now it is shifted from the cluster to the cluster 1. So shifting happened. Shifting happened means we again have to calculate the centroid of both the clusters. It is an iterative process. The second iteration I'm talking about. So now it is the new center of the cluster 1. Similarly, we have to calculate the new center of the cluster 2. Same process. This represents the distance of all the data points from the new cluster, new centroid C1. Similarly, these are the distance of all the data points to the new centroid C2. And based on the distance, I have to label it. So these two data items are closer to the C1. That's why it's a part of cluster 1. These two data items are closer to the C2. That's a part of cluster 2. Now you can understand what were the cluster assignment you have observed in the earlier iteration. The same belongingness you have observed means data item stop moving. So means whatever the observation you have understood over there, look over there. That is the answer of the after the cluster you have received after second iteration. The same assignment you have observed after the third iteration. Means what is the meaning of that? It is also, I have written in the note, found no changes in the cluster. Data points are stop moving. This means the clustering process over. This means that is converged. Stopping, one of the stopping criteria matched. What was the one of the stopping criteria? When the movement of the data point stopped, we have to stop the clustering. So these are the final cluster. Agree? So these are the two data point. AB is the AB in cluster 1 and CD in the cluster 2. So if you try to recall, yeah, these are the AB, these are the CD. So CD is the part of second cluster, AB is the part of first cluster. Means through our understanding, whatever the answer we have imagined, the same answer is given by your clustering process. Okay, now the most important discussion I'm going to start, how to choose the appropriate number of cluster. Like I have promised you, you can start randomly with any value of the k. There are some method that will help you to find out the suitable value of the k. So what are those methods I'm going to discuss? One of the best method to find the optimal value of the k is the elbow method. So the procedure of the elbow method is written over here. I will not go into the discussion. I will explain through the example how it works. So we have a two objective function, any objective function you can consider, either homogeneity or either heterogeneity. In the both the case, you will get the same answer. So I'm going to explain by using the homogeneity. To try to focus on this graph I'm going to explain over there. So y-axis represent the homogeneity. Within group homogeneity means homogeneity I'm talking about, the intra-cluster distance I'm talking about. And x-axis represent the number of cluster 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So see over there. Suppose start with the minimum value of the k. What is the possible minimum value of the k? That is equal to 2. At least two group you require. So suppose the k is equal to true, k is equal to 2, you have executed your algorithm completely. Whatever the cluster you got it, suppose the homogeneity is this one. This is the y-axis represent the homogeneity. Now you change the k is equal to 3. Again, need to execute full algorithm, and after the conversion completely execution process is over, you have to again calculate the homogeneity. You observe that with the k is equal to 3, homogeneity increased. Earlier homogeneity was here, now the homogeneity increased. So that is the thumb rule. I am not uh, I will not go into the detail why it happened. That is a phenomena that the moment you will increase the value of the k, homogeneity will always increase. I am repeating again. There is a phenomenon that the moment you will increase the value of the k, the homogeneity always increase. Why? I am not going to discuss for today discussion, but try to remember that. So what is happening over there? That graph will not go down. It will go up, 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 up. It will not go down. So the moment you are increasing the value of the k, homogeneity also increasing, Then where should we stop here? The answer is that you have to see the sharp turn. So that is the sharp turn, means even though we're increasing the value of the k, the homogeneity also increasing, but the magnitude, that amount of performance hike is very minute, very less. So the moment you can visualize that turning point, that is called elbow. We have also our elbow is a turning point of our hand. Similarly, these are the hand, this is the elbow. So against that turning point, you have to see the value of k. Suppose the value of k is equal to 3, means ideal value you should choose for that given data set will be k is equal to 3. I hope I have made it clear. Similarly, another diagram you can explain over here. You can understand over there. The x-axis represent the number of k, y-axis represent the homogeneity, and you have to find out the elbow of that graph. So intentionally I have pasted that graph over here. That is a limitation of the elbow method. Is that sometime may happen you are not able to find out the turning point. Like this graph, you cannot find out the turning point. Somebody will say I should consider k is equal to 5, somebody will say k is equal to 6. So that is the limitation, we have to work with that. One of the question I got it, is this value the max value of the k? Yeah, the max for the hard clustering, the max value of the k is equal to the total number of data items. Suppose I have a 10 data items, 10 number of observations. So you cannot fix the k is equal to 11. You can fix the k is equal to up to 10. So you have to check the homogeneity with respect to all the possible value of the k from k is equal to 2 to k is equal to 10. Through that graph, you have to observe where is the turning point. Suppose turning point, like in that paragraph, you observe that the turning point is with respect to the k is equal to 4. So k is equal to 4 is the optimal value of the cluster. Means if you set the k is equal to 4, whatever the cluster you will get, that cluster will be optimal cluster. So data points within those clusters will share the similar property. Otherwise, more number of cluster means more data items are more scattered. So optimal number of cluster, I mean to say, that is the condition where the homogeneity and heterogeneity will satisfied as the ideal cases of the best result it will give. Another word you can say. So that is enough, and from my side for having a discussion about the k-means clustering. So now I will go for having implementation by using R. So meanwhile, if someone have any question, any doubt, they can write on the chat box. Otherwise, I'm going to have a discussion on the implementation. So any questions, please write on the chat box.
If anybody wants to ask directly, then they can raise their hands also. We can unmute you.
Okay, no issue. So now, okay. So
Manish Dhakad is raising hand, sir.
please ask.
Let me let me check, sir. I have to unmute him first. Then he will be able to ask.
I have unmuted him, ma'am.
Okay, sir.
Manish, Manish, Manish Dhakar. Manish Dhakar.
Manish Thakur, you have to unmute yourself. We have unmuted you from here. You have to unmute from your side also. Then you will be able to speak.
Okay, no issue. If he want, he can write. He can
Oh,
write on the
chat box.
chat box.
Okay. Okay, sir.
Okay, sir. Okay, sir.
Okay, so
Good.
let me know my R editor or screen is visible to you.
Yes, sir.
Yes, sir.
Okay, thank you. So mm, I'm going to open 1 minute my data set. I will show you.
Participants, you can zoom out also. Editor screen is generally in small size only. It appears in small size because it's the terminal screen. So if you will zoom out your screen, then font size will get bigger.
Okay, so I think the first lecture is taken by Mr. Amit Jain. So
Yes, sir.
I hope he has demonstrated very initial command of the R uh, uh, like get WD, set WD, and basic fundamental. I hope he has demonstrated.
Yes, sir. Yes, sir. Yes, sir.
Okay, so I'm not going into the much detailed discussion like that. How to download the R Studio, how to install it, how to run it. Okay,
No
so
need. No need, sir.
sure. So first, let me explain what the dataset I am taking for discussion. So the dataset I have downloaded from the internet. That is from a freely available dataset, a wholesale customer dataset. You can search. You can also have a download. It is not a big issue. So that dataset having a 8 characteristics. The dataset have a please look over there. This is the dataset that is a CSV file. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 features of the dataset is given over there. Sometimes we call it feature, sometimes we call it variable, sometimes we call it characteristics. So these are the common word normally we talk about. So I will consider the data set as an input. I will apply the key means clustering on that data set. I will try to develop the cluster. So here, a little bit have a more discussion about the data set. So here data set a little bit, let me explain. The phrase is the one of the variable or one of the characteristics of the data set that represent the annual spending, maybe in rupees you can consider, annual spending in rupees for purchasing the fresh product. So suppose I am a Vivek Tiwari, I am the customer of the Big Bazaar. How much item I normally purchase that comes under the fresh product, or how much money I normally spend to purchasing the fresh product. So that is the data, that is the things it explain about. It is written continuous. Continuous means it is a category of variable. It is written over there. Continuous means it is a numerical value. Similarly, the next feature milk is same as also annual spending, maybe in rupees, on the milk product. Grocery, similarly annual spending, similarly annual spending for the another item set. So these are the some numerical variable. Last two variable channel and region try to understand. Channel means it talk about which category of particular person it. it is a retail customer, individually he is purchasing, or he is belongs to the particular hotel or restaurant. So there's a two category of customer, whether it is a retail customer or it is from the hotel or restaurant. Similarly, reason is also one of the variable that will explain about the particular customer that belongs to the which region. For the simplicity, you may consider it as a, suppose a Bhopal. So you belongs to the Kolar or belongs to the New Market or Patel Nagar, like that. So one, okay, yeah. Here, some of the feature I have to drop it. I have to remove the feature channel and the region from the data set. If I consider, if I feed that data set exactly same as that is given to me to the clustering algorithm, the result, whatever we will receive, will not be the, you cannot interpret that result, or results are not acceptable. Why? Reason is that you can understand that first six of variables are written over there. These are the numerical variables. These are the continuous variables. Last two variables, channel and region, are the categorical variable. So I hope many of you can understand what is the meaning of nominal, categorical, continuous, numerical variable. Categorical variable means it belongs to the category, like whether I am male or female, whether I am a resident of MP, yes or no. So these are the categorical variable. Whether my reason of my belongingness means you are from the New Market, you are from the Kolar, you are from the Patel Nagar. So these are the category. So you cannot feed category under the any distance matrix function. Like suppose you are using the Euclidean distance, whatever the variable you are feeding the Euclidean distance, that variable must be a numerical variable. You cannot calculate the distance between male and female. You cannot calculate the distance between South Indian and North Indian, like that. So similarly, these two variables, 7 or 8, are the categorical variable. It is already mentioned over there, nominal. Nominal means categorical variable. So that is the one of the fundamental guideline everybody should follow. Whatever the data set is given to you, you try to export that data set. If all those variables that are the categorical variable, remove from the data set all those categorical variable, and remaining variable must be a numerical variable. Try to feed that data set to the clustering method. So first I will try to load the data. So there is a command read.csv. Read.csv is a very simple command. If data set in the CSV file, and that is a data set name, whole customer.data.csv. Look, that is the CSV file. I have to pass that name into that function, and function will do everything for you. So suppose I have a copy that command, and there is a R editor. I think it is visible to you. If my editor is not visible to anybody, please let me know. So I have just run that command. It is taking too much time. I don't know. Okay, why? So that is the read.csv, the function I have used. Okay, I'm audible. So now
Yes, sir. Yes, sir. Yes, sir. Screen is also visible.
Okay, thank you. So the data is a variable. You can give the variable name as per your easiness, like A, B, C, X, Y, Z. So this is the variable I have created. The read function I have taken. There is a whole data set were in the CSV file in my hard disk. I have uploaded that data, and read.csv command import that data and store into the data. So now I have to work in only the data. Data is the variable. Full data, whatever the data I have shown to you in the CSV file, now it is stored into a single variable data. You can see it. Look, whatever the data was there, it is here. Complete data set. The channel and region I have to remove. Okay, so that is the complete data set. The variable name I have right over there, and click, it will show all the data set that are already stored in the data variable. So go to the next. Okay, so it is written. We will need to drop the channel and region variable because these two are the categorical variable or ID variable. So what is the command to drop it? So okay, let me explain over here. So what I'm doing over here, I am creating a new variable data1. There were already a data that is a variable that contain all the complete data set. In that syntax, I have to command to index value. First index value is empty. Empty means the complete first index value represent the total number of rows. After comma, second index value represent the total number of column. So if I kept empty, the row index value means complete row I am taking, complete row I am considering, and against the column index value minus 1 or 2. In R, the index value start from 1, not from 0. So what is the meaning of that? Minus means what? It is, you can understand that in real data set, the column, there are 8 column. Column number 1 and 2 with minus value, it is going to drop these 2 columns. So minus column index 1, column index 2 means it is not going to consider these 2 columns. Okay, and it is going to consider all the rows. That's why I kept empty at the row index. So the moment you will run that command, it will filter that data based on your requirement. It is going to drop. It is going to drop these 2 columns. Now data 1, you can see whether you are getting the desired results or not. You can see now fresh, milk, grocery, frozen, detergent, and other like that. The channel and what was the another column? It is removed. It is gone. That was the channel and region. Channel was as the first index. Region was at the second index. These 2 are removed. Now data1 is the variable that is really contain real data set where I. So now I have to apply the k-means clustering algorithm. So like a Python or R or MATLAB, that are the best tool for implementing any machine learning algorithms, and all the packages, all the functions are already pre-written, pre-built, and you can directly use for your purpose. So the k means the function in the R already there, like a header file in the C++. You don't need to implement the k-means clustering from the scratch. However, you want to see the complete code, you can go to the help and type the k-means. Under the k-means, how the complete algorithm, whatever I have explained in the last 1 hour, it is implemented there. The Euclidean functions, through distance matrix, through data frame, everything is there. Through stropping criteria, everything is defined over there under the k-means function. So I'm not going to implement the algorithm from the scratch. Algorithm already implemented, I'm going to use the function. So that is a function. I have to pass only 2 variables. You want to apply the k-means clustering on which data set? I want to apply on the data1. Data1 is the data set I have. How many cluster you want? 5. So k is equal to 5. So like I have explained in the k-means clustering algorithm, user have to give the value of k. So I hope it is clear to everybody. I'm going to run that command. Okay, it is over. Within a 1 line, full complete k-means clustering algorithm is over. It is iteration is over, multiple iteration is over, multiple time assignment updation process is over, Euclidean distance has been calculated, and what happened, stopping criteria they have matched many times, and algorithm already converged, and cluster is already created. So within a second, one function have done everything for you. Now go to the detail. I want to discuss more. I want to see the cluster property. So the clustering is created. What are the cluster? I want to see the property. Okay. So please try to focus over there. A little bit important thing I will discuss. You see the clustering process, whatever I have done, the clustering process, it has created 5 cluster. This is the cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. Now, under the cluster 1, how can I explain you? Take the example of the milk. Take the example of the milk. There is a cluster number 5. Cluster number 5 are the cluster that contain the set of peoples, a set of customer that normally spend 38,000 rupees for purchasing the milk annually. What I am trying to explain you, clustering only create the cluster. After that, what are the pattern over there? What are the trend over there? You have to dive into the detail. The clustering process cannot give the sentence like these are the pattern, these are the trend hidden over there. Domain knowledge required. We have to analyze each and every cluster and try to find out the pattern like right now I'm doing. What I'm doing? I'm seeing against the milk. These are the annual spending of the people. So I get to know 38,000 rupees annually people are spending who belong to the cluster 5. And the cluster 1 are those only those peoples that spend only 3,000 rupees per year for purchasing the milk or milk related product. So you can think over there. Suppose you have a new milk product, what you will do? Whom you will contact? If you have a new milk product, definitely you will go all the customers that belong to the cluster 5, because these are the people that are really spend a lot of money on the milk or milk related product, or these are the people they are very less spend on the milk. In see the holistic way, these are the cluster 1 except the fresh grocery, against milk, against grocery, against frozen item. These cluster are poorly performed. Means you can imagine that, you can think like that, maybe I am wrong. The cluster 1 contain the peoples that are that belongs to the poorly economical background. They are poor peoples. Economically background, they belongs to the little bit poor background, poor economic background, they belongs to that. That's why they are spending less in grocery purchase, milk purchase, and frozen item purchase. Similarly, the peoples are belongs to the cluster 5 are rich one. They are spending a lot on purchasing the milk, grocery, and frozen. Another way you can also think that these may be possible. The cluster 5 contain mostly persons that belongs to the restaurant and hotels. So they used to purchase milk and grocery other items in the huge amount. So in that way you can analyze the clustering results. 1 minute. Any questions? Editor is not visible, somebody is saying. My R editor is visible to everybody?
Yes, sir, it is visible.
Okay, because somebody have written for that one, it is not visible. Okay, let it go. Somebody, so a question of Keshav Sharma from YouTube. What is the P value? Okay, so I'm very surprised to see today in my discussion where the P value I have discussed. P value, I think I didn't discuss about the P value. Okay, so okay, YouTube from somebody have asked. Okay, let me explain. The P value is something that is more related to the linear regression or some statistical analysis, where P values talk about significance level of the something. Normally p-value range, no, p-value, any parameter, any features that gives a p-value less than 5% or 0.05, we normally consider as an important feature. So p-value is talk about it. It helps us to identify against any result, any feature, whether it is significant or not. Significant means I mean to over here. Suppose I will say I want to predict whether a student is going to place or going to have a success in coming placement drive or not. The student is in second year. I want to predict he is going to be placed or not. So for predicting such kind of things, I need required some internal feature like the performance of 10th and 12th CGPA, first year CGPA, second year CGPA of particular student, his technical skills, his how many project he has gone through, how many languages he know. So many features I want to know. Suppose now I'm going to ask a questions whether a roll number of particular student is going to decide the student is going to be success in placement drive or not. Try to understand my question. Whether roll number of particular student is important to decide that a student is going to success in coming placement drive or not. Not at all. But if I say the communication skill is how important to decide whether a student is going to success in placement or not. So somebody will agree the technical skill or communication skill is an important feature. It is a significant feature that is really influence the success. But my roll number does not important feature. So how do you know all those things? If you have a background knowledge, you do know. But if you don't have a background knowledge, then p-value comes into the picture. Against each and every variable, we have to calculate the p-value, and based on the p-value, we can decide the given feature is important or not. If the features p-value is less than 5%, it is important. If features value is greater than 5%, it is not important. It would be better if we could we could discuss about the p-value with respect to the linear regression. So in the clustering process, I think I didn't discuss about the p-value. That's why I think it is enough for today's discussion. Okay. Now for next, I have to go over here. Okay. So now, if somebody want to see the how many items each cluster contain, so I have a command that it is visible to everybody. This is the table. Table is already a command. So K is the output of the clustering process I have stored in the variable K. So K dollar, the cluster is a command. The moment you will fire that command, it will going to show how many observations belong to the each cluster. Like that, cluster 1 contain 106 observations or 106 customers, you can say. Cluster 2 contain 233 customers. Cluster 3 contain 81 observation. Cluster 4 and cluster 5, like that. So in this way, that command you can visualize all those. Next, we had discussed a lot about the homogeneity and heterogeneity. Homogeneity means the intra-cluster distance and heterogeneity means intra-cluster distance. So how to measure the homogeneity and heterogeneity? So there is the keyword within SSE. Within SSE represent the homogeneity and between SSE represent the heterogeneity. So first I am going to measure and display the within SSE. So that is the things I'm going to explain over there. You see the result. That is the within SSE of the cluster 1, within SSE the cluster 2, cluster 3, cluster 4, cluster 5. That within SSE means suppose the cluster 1 have 106 observations. So that is the Euclidean distance, the sum of the Euclidean distance between all the data points of the cluster 1. Means data point 1, suppose there is a 106 data points. So data point 1, I have to calculate the distance from remaining 105 data items. Similarly, for the second data item, I have to calculate the distance from other 105 data items. Then I have to sum it. That is called within SSE. Within SSE of the cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. Similarly, I need to see the heterogeneity, or that is called between SSE. That is a single value. So we had a 5 cluster. So what is the distance between all these 5 clusters? We are going to represent by using the between SSE. So here what need to do? Each cluster have a centroid. Then we have a 5 centroid. Then we have to calculate the distance between these 5 centroids, and that is the summation of those distances. It is called heterogeneity. We try to maximize it. Now, okay. So elbow method. How to implement the elbow method? I'm going to discuss about. I already discussed about the elbow method. So let me explain the code. I will not go into the detail. So in the elbow method, I have to run my algorithm with all the possible value of the k. For the simplicity, here I am running my algorithm for k is equal to 2 to k is equal to 20. Means x-axis, I will start my x-axis from the k is equal to 2. I will execute my clustering algorithm. I will calculate the homogeneity. I will store somewhere else. Then the k is equal to 2, then k is equal to 3, then k is equal to 4, then k is equal to 5. Similarly, these are the variable where I am going to store the average SSE, average homogeneity with respect to each and every value of the k. The size of that variable should be equal to the size of total different value of the k I'm going to consider. So that's why the range is 19. If you consider the variable, the length of range variable, it would be 19. So the vector I'm going to create over here, the size of exactly all the with respect to the possible value of the k. So that is the command I have to run it, then see whether it is going to create elbow method for me or not for this given data set. And price means h with respect to every k value, I am running my algorithm 100 times, because in each and every time my algorithm may give different results. So I'm going to summarize the more general performance of my algorithms. That's why I have to run algorithm 100 times. So that is the code. It will do everything for you, whatever I have explained over there. Look, the variable v, it will execute from 0 v from 2 to 20, and against each value of v, it will execute algorithm 100 times, and after 100 times you will have 100 homogeneity, and 100 homogeneity, then we have to store the average SSE with respect to the each k value in this variable. Then again we have to calculate that variable. So suppose that code in very fast way I have explained that, don't worry about that. It is executing execution over. Then I want to visualize that data. What is the for understanding the code little bit, you have to dive into the syntax of R. Look, right hand side here, these are the elbow method. Look, k is equal to 2 to k is equal to 20 x-axis, y-axis is the total within SSE, and you can consider the homogeneity. Maybe somebody will say k is equal to 6, k is equal to 7. That is open to up to you. There is no another way to decide the exact value of the k is equal to 5, k is equal to 6, k is equal to 7. So based on your understanding, where you visualize the turning point, you can consider the k is equal to ideal value. It may be 6 or 7 like that, for my understanding. So this is the way you can execute the elbow method to decide the optimal value. Another things I will also try to explain over there. Suppose I want to visualize So there is two library you can use. The cluster is a library. Already I have run over there. And another library is the FPC. These two library you have to install on your system, and you have to include in your R. Once you have successfully included these two libraries, you can visualize the clustering results. So plot cluster is a function that is already explained in the FPC packages. If that package is a part of your R environment, you can directly run that package. So I'm going to run that package and see what happens. The function. Okay, so the plot cluster is a function. Data is a data set I have used. The data one you can also do. And the K, that is the result of the clustering process you have stored. So you execute, you try to execute it and see the results. You see the cluster visualization over here. Yeah, this is the visualization. So these are the data points of the cluster 5. Very few data points comes under the cluster 5. These are lighter colored, green colored data points are the cluster 3. Red colors are the cluster 2. Black color data points are the cluster 1, and blue color are the part of cluster 4. So in this way you can also visualize the your data. So okay, so that is enough from my side. Okay, so I know a little bit faster way. Quickly I have wind up the implementation part, because it is normally based on the syntax. So if you are comfortable syntax with respect to the R or Python, whatever you want, all the implementation are available on the Google. You can explore based on your choice. So from my side it is over. So now I'm going to open the discussion session. So you can unmute yourself and ask the questions or doubt, anything you want to have a discussion, please.
Participants, if you want to ask any questions, then drop your questions in the chat box or raise your hand. Any questions from participants? Please drop your questions in the chat box.
Okay, no issue, ma'am. You can share my mail ID. If later they can have some confusion and any doubt, they can write to me directly. So not an issue.
Okay, sir. Chandan sir, am I audible to you?
Yes. Am I audible?
Yes, sir. Continue.
Thank you, sir. I thank you so much, sir, for this informative and great session, which enhanced our knowledge about descriptive data analytics through clustering using R. I hope that all participants are now able to do the implementation of R in the above field. I am extremely privileged to have you all here today, sir. Furthermore, I appreciate your valuable time and patience you have shown today. Again, behalf of our Truck family, I am thanking you so much, sir, for being with us. Feedback
Thank
link
you.
is yes, sir. Thank you.
Thank you.
Thank
Thank
you
you
so
from
much.
my side. You have considered me, contacted me, and given this opportunity to have a discussion with other participants. And after many years, I think I'm just seeing Sonal Madam, because we worked earlier together in Bansal Group. So
Okay.
after many years, I am seeing her. Okay, it was a really nice experience, a nice discussion.
Thank you, sir. Thank you.
Thank you, sir. Dear participants, feedback link is shared in the chat box and on YouTube channel too. And I have also mailed the complete information of day 1 of session 1 and 2 to all participants. Thank you all. Thank you,
Okay,
ma'am.
madam. Okay, may I leave now,
Okay,
madam?
sir. Yeah, sure, sir.
Okay,
Thank
thank
you
you.
so much, sir, for your
Thank you.
precious time.
Thank you.
Okay, sir.
Irfan sir, we do not close the meeting. I have to put the feedback link तो डाला है नहीं।
Sir, we can share feedback link in the chat box also, no? Oh, sorry, in our WhatsApp group also.
हाँ हाँ
So participants, you will get feedback link in the WhatsApp. Okay. From there, you can get the link and you have to fill that feedback form too. And tomorrow we will continue at 10 a.m. sharp for third session. So Taggy sir, should we end it? Okay sir, thank you. And thanks to one and all present here. You can leave now. Thank you. Some students are not in WhatsApp group. Sir, could you share that WhatsApp link in our this Zoom?
I am trying, ma'am.
Those who are still not joined in WhatsApp group, then wait for a moment. So we'll share the link in this chat box only.
WhatsApp group link is already shared, already sent to the mail on their mail ID. Kindly refer to your mail. You will get the WhatsApp link with there. I have mailed all the information regarding day 1 sessions to all the participants. Kindly check your email. You will get all the things. Thank you. Thank you, ma'am.
Yeah, thank you, sir. And I am able to see that feedback link is also shared in the chat box right now.
I have also mailed to all the participants.
Okay, sir. Okay. Thank you, sir.